In this project, we explored the utilization of Go.RL agents, a framework combining the Godot game engine with reinforcement learning algorithms to train video game assets in the Godot engine. We investigated the potential of using machine learning to enhance the behavior and intelligence of game assets, covering scenarios such as non-player characters and procedural content generation. A direct comparison was performed using two builds of the ring pong game. In build 1, the paddle is controlled by the player input and the physics process function, and in the second build, the paddle's behavior is controlled by the Godot RL Agents Framework, a reinforcement learning plugin for Godot developed by Edward Beeching. The Godot RL Agents Framework contains wrappers for 4 RL frameworks: Stable Baseline 3, Sample Factory, Ray RLib, and Clean RL. For our comparison, we used 2 instances of Godot running the separate versions of the game used in this study, the player-controlled version and the machine learning version. Because the build of this game is designed to utilize the Godot RL Agents framework, each game runs 8 instances of the game at once. This works very well for the machine learning version of the game, since more learning iterations can happen at once and each game instance is controlled separately by the actively trained model, whereas it is not quite as useful on the manually controlled side, as all games share an input, meaning that the entropy of the ball can lead to some uneven gameplay for the player-controlled paddles, with the ball going in different directions in each instance of the game. Much of the effort spent in this study, as a part of the research experience, was in configuration and setup. At first, I tried to use Debian 11 for the OS on the machine I planned to do the experiment on. I ran into driver issues, pathing issues, issues with pip permissions, and I even started going down the path of using pipx rather than pip. Some of the dependencies were missing. While setup was possible, I decided to scrap the idea of using Debian in favor of using Ubuntu, since I am planning on implementing things learned from this research experience with students in a classroom setting. The fewer technical roadblocks, the better. My experience in setting up Godot with the Godot RL Agents framework went better on Ubuntu. I was able to get further along and closer to setup, but ran into significant issues with mismatched gym environments with stable baselines, and was unable to get things working at first. I could find no solution to my issues while endlessly searching Stack Exchange posts, GitHub issues and pull requests, and Reddit posts. I was finally able to locate someone who had found a solution on a small Discord server. This individual had forked the repository, and that included the necessary fix. I was able to pull the Godot RL Agents repo to my machine from the updated fork. I will include these specific steps when building out the lesson plans for my students. After I ran the fixed pip install, I was in business. I was then able to load the manually controlled version of the ring pong game, install the Godot RL Agents plugin from the asset library within the Godot editor, and proceed to configure the agent for the ring pong game. Next, we added the AI controller script, which is part of the Godot RL Agents plugin, to a child node under the player node in the player scene. We created a class that inherits from the AI controller 3D script by extending the script and creating a new one called controller.gd. We added 4 methods to the extended script that define observation, reward, and actions. These functions were function getObs, function getReward, function getActionSpace, and function setAction. We then updated the player script to use actions from this AI controller we built. Lastly, we added a sync node to the root node of the training scene. This node allows our Python tools from the Godot RL framework to communicate with Godot locally via TCP. The sync node also had the action repeat and speed up options, with both allow for quicker RL iterations to save time. Once configuration was complete, I was able to effectively use this reinforcement learning tool to train the paddle control in the ring pong game. There were several ways to achieve this. The first way I did this was by calling the GDRL bash script with Godot RL Agents in a separate window, which listens for a TCP session from Godot. I'd run the script and play the game within the editor, and all 8 game sessions would start playing automatically. The paddles would move around a bit at first, aimlessly, but after many iterations of negative reinforcement from the ball hitting the perimeter of the paddle would become much more effective at keeping the ball in play without getting a game over. The other way I was able to achieve this was with the CleanRL Python script, which also listened over TCP and had similar issues in training the paddle behavior. Finally, as you can see, I was able to get the 2 builds running side by side to make our comparisons.